Good morning, everybody. Welcome to Karmada bi-weekly English meeting. Can you hear me okay?
Yeah, we can hear you.
Yeah.
I can hear you. Sorry about my background noise. And let's see. Let's wait another 30 seconds, waiting for people to join the meeting, and then I will go started. All right, let's get started. Hello, everybody. My name is Ying. I'm a software engineer at Zendesk. Our company is adapting Karmada to managing the Kubernetes cluster, and I'm excited to be your host for the meeting today. Let's take a look what's on our agenda today. A cluster proxy enhancement. Wei Zheng and Changzhen gonna show us the cluster proxy that are on wire of the clusters. And just a logical reminder before we get started, this meeting will be recorded and will be available on YouTube Karmada later today. And I'm gonna hand it over to you. Oh wait, I'm gonna stop sharing.
I can hear.
My end.
Okay. Okay, I show my screen. So can you see my screen?
Yeah, I can see your screen.
Okay. So today I want to give a overview about implementation about class proxy enhancement. Okay, first let's see the background. When deploying service in web cluster, it's often necessary to query source from this cluster in a unified manner and without needing to know the specific location of each resource. This including operations such as get, describe, list, logs, and exec. Also, additionally, Karmada is commonly used in multi-tenant environments where users shouldn't have access to other user resources like secrets, config map. It's secret information. So this is always achieved through RBAC implementation, which means the query operations must adhere to the privilege limitations set by RBAC. So this is the background. And what's the current situation? Now, to support a unified query train, Karmada provides two kinds of proxy, cluster proxy and search proxy. So here I list three kinds of operations. You can use cluster proxy with kubectl, kube control, and cluster proxy with command control, and also search proxy. The first is perceived memory cluster. With a cluster with kube control, yeah, you need to specify the cluster name in the query URL. Then you can query the resource from specific cluster. Same with this one. Search proxy, because the resource is cached in control plane, we don't need to perceive the memory cluster. And secondly is that here the RBAC limitation memory clusters. For this one, because the query request is routed to memory cluster, so the RBAC is can limit the request. Same with this one. This one, because there is also I think I I presented in last meeting. The search proxy, the RBAC is not work in this situation. About the operations, get list, describe logs, exec, all of them are support these operations. So, but what we are expecting? What we are expecting is we don't need to perceive member cluster, and we want to adhere the RBAC limitations in member cluster, and we want to support get describe list logs exe operations. This is what we want. So from the table here, we can see none of them satisfy these requirements. So we just give enhancement to cluster proxy. From this, the logic is quite simple. We can see here the user query source from proxy provided by Karmada. Cluster proxy or search proxy, it doesn't matter. Then step one, it will query and find the location. Like you query deployment index, it will query from all the cluster and find the, where exactly it's located. Then step two, it will route request to the target cluster, then return the resource to users. So here, if the privilege like cluster one is not allowed to query source, the cluster will be skipped if they are back limit these operations. Okay, then so here we can see we just need to specify resource like I need to query deployment index. Then you don't need to perceive the memory cluster. The resource will be returned. So what's the limitation? Because like so here we can I list all of the operations get describe logs exec. Now it lacks a good support for querying resource in multiple cluster with same name. It will return conflicts information like deployment exists in multiple cluster, cluster 1, cluster 2. So you need to use some workaround to fix this workaround to query resource with same name in multiple cluster. For list operation, it has line limitations. So if there is a conflict, follow these steps can find a workaround. First is enhance kube control. Here is the issue. It propose a header, customer header, and you can use kubectl with like add a customer header cluster equals member one. Then the request will route it to member cluster one. But temporarily, this feature is not really, work because we need to process this more because it's not implemented yet in Kubernetes. So second is use Karmada control. If there is no conflicts, Karmada will execute the operations directly, like find the target cluster and query resource and return it. However, if conflicts exist, you need to specify the cluster, like Karmada control get deployments can say cluster one. Then you can query resource from specific cluster. Okay, this is what I want to show. If there are any questions, you can ask. You can directly ask. Okay, if no question, I think we can see.
I have one quick question, if that's okay.
Okay, please.
Thanks for presenting this. Just one question. Any idea when we could start testing this? I know from Zendesk, this is one of the big features we've been waiting for, and being able to test this out right away would be great.
Sorry, please. Can you pardon?
Sorry. Is there like a date when we will be able to test this new feature? At Zendesk, we've been waiting to, and it would be great. if we can start testing it.
I think we will soon, we will soon finish this feature maybe this month, or I'm sure it will be achieved before next release, but I'm not sure. This will Hongcai, can you give a estimate time about this feature?
Yeah, we planned the feature in the next 1.7 release, and the release will be cut at the end of the August next month, end of the next month, I think.
Perfect, thank you.
Oh, okay.
Actually, I'm thinking of these limitations. Sorry if it deviates from current topic a little bit. For example, if we're looking at the get operation, can it just return a vector, array of the resource?
For list, it does, but for get operations, like kubectl control, it only accept not arrow objects. If you return arrow objects for get operation, it will have arrow information output. Yeah.
Okay, so there's no way to suppress the arrow?
Yes, temporarily no. There is no way to. Yeah.
Okay.
Yeah, but here is a workaround. You can, use command control, or we will give a issue or KEP in Kubernetes about to enhance the kube control next. Okay, if no more questions, let's see about this demo show. Chanzhen will give us about these operations. Give us show about these operations. Okay, I stopped sharing my screen.
Hello, I will share my screen. Wait a moment.
No.
Can you hear my screen?
Yes, we can see. Yeah, Karmada logo.
Yeah. I just install an Karmada with kind use Heco lookup script. Let me demonstrate the demo for the okay. This demo demonstrates how to perform resource operation. Use kubectl. When operating, there is no need to provide a class to information, and it completes with the member RBAC. So let's begin to do it step by step. First, let us create service account Tom that don't have any permission in the member cluster. We have 3 member clusters. Member 1, 2, 3, and we create Tom in them. Okay. The second step is create the Tom service account in the Karmada control plane. And then we can grant the class proxy permission for Tom. This is YAML. we can copy it. Sorry, add this. We grant a class proxy for resource member 1, 2, 3, and the mask for all resource. And we can apply it. Okay. And the third step is access resource in member clusters. Before that, we need to get the secret from the Tom. We manually create a long-lived API token for Tom service account. And get the token. We need to construct a kube config for Tom. This is a file. We can copy the token to here. And we need to get the Command API server address from the Command API pointer config and append the this value to the address. Oh, sorry. Oh, sorry. Let us say the Command API server address and copy it. Copy it. Okay. Let's make sure it's correct. Well, and then we can run the command to get the pod and nodes resource in the memory cluster. We can see that we cannot get list the resource because we don't have the permission on the member clusters. So in the next step, we need to grant the permission to Tom in the member cluster. First, we grant the permission in member 1 clusters. Okay, we can see we grant the Tom with pods, nodes, pod locks, pod exec, and the verb is get list create. The pod logs is for logs permission, and the pod exec is for exec permission. And the create verb is also for exec permission. We can apply it in the member 1 cluster. And we can get with the before command. We can see the all pod in the all pods in the member one and node is member one control plane because we only grant the permission on member one cluster. Then we grant the permission on member two and member three. It's the same RPC YAML. And then we can get the pods again. We can say those pods on all three member clusters and the nodes on them. Next, we can we'll win the logs of pod in the member cluster. We choose one pod randomly. Oh, sorry. It needs the namespace information. Okay. Hey, okay. We can say the logs. Let's choose another one. Ooh. Let's choose this. Okay, it's successful. And then we can exe the pods in the member clusters. We choose one pod. Okay. Choose this one. This one we can. Oh, sorry. We need to this command. Okay, we run into the command. Run into the container. If we get the same resource in two clusters, we will get a conflict. We let give us so. Let me give us so. Sorry, no, not this one. Let's grant the deployments for Tom. In all three members. Okay. Now we can get deployment resource. Oh, sorry. Let me make a think. Oh. Sorry. I will do it later. In my project, I do it successful. Something maybe wrong. Some implementation details and error handling is still rough. I will we will be gradually improve it. Thanks.
Thanks. So I have a question. So if there is a multiple resource with same name, it will give an error like conflict chain, right?
Yeah. This will get an error, but something is sorry.
Yeah, I think that's okay. Yeah, you don't need to demo the limitation because I think you will continue to find a better solution for this, right?
Yeah, yes.
Okay.
Okay. That's my demo. So
Yeah, I just see Linus online. Hello, Linus.
Yes, hi.
Hi.
Right. Thank you so much for your present and the demo for the proxy enhancement.
Linus,
Just
do you have
wondering.
any questions?
Yep. Any questions?
Oh, yeah, not at the moment. Thank you.
I think from our ends, like we don't have any questions so far.
Okay.
But we
I
will
think-
discuss internally.
Yeah, I think the first thing is once we get to see it and we can see the failure state and how the error handling is, that will help us, I think, understand maybe what we need to either add to it or we need to build ourselves for our engineers here at Zendesk. But until we can see all those error states, I think it'll be a bit hard to know that too much ahead of time.
Does anyone have any questions outside of the agenda? Nothing once. Okay, cool. I think that's all for today. And thanks everyone for joining the meeting. And next meeting will be in 2 weeks from now, gonna be August 25th. Yeah, sorry, it's not August, July 25th. Cool. And thanks again, and I will see you next time. Have a great rest of your day.
Thank you.
Thanks.
Bye-bye.
Thank you.
Bye.